Hello, my name is Wyatt Briggs. I'm a coastal and environmental biology major here at UNF. I would like to welcome you all to my presentation, Crustacean Frustration, the Multifaceted Top-Down Effects of Burrowing Crab Species on Salt Marshes. Just going to start you guys off with some background information on salt marshes. So salt marshes are coastal tidal communities that occur when river deltas empty out into the ocean. This creates a mixture of salt and fresh water that creates a very high amount of biodiversity. We get lots of very commercially important species that live in salt marshes, things like blue crabs, oysters, and red snapper. These ecosystems are also very ecologically important as they act as barriers to prevent coastal erosion from wave energy. This is especially important now as we are seeing an increase in sea level as well as hurricane intensity due to climate change. They are also very well known for sequestering high amounts of blue carbon. The soil in salt marshes is flooded and anoxic, so there's very little decomposition that occurs within the soil. So as new plant material is generated, it piles on top of the old growth, sealing it away and acting as a carbon sink. Now for some background on the star of the show here, marsh crabs. I focused primarily on common species found in North and South America, which are fiddler crabs, purple marsh crabs, who we can see here in this photo, and granulated crabs. All three of these crab species can alter their environment greatly due to often being herbivorous and feeding on cord grasses that dominate these salt marshes. They also construct lots of little burrows within the soil, which, as we will soon see, can cause lots of various effects on the ecosystems. This is because those burrows increase air and water flow through the soil. They can increase the amount of nutrient deposition in the soil, and also in some cases can actually increase erosion rates in salt marshes. Right, so why does it matter? Crabs are digging holes in the marsh. Why should we care about it? Salt marshes are some of the most productive ecosystems on Earth and play major key roles in helping coastal communities resist the impacts caused by climate change. Because of this, they must be protected and preserved in any way we can help them. This research is important because salt marshes were previously believed to be controlled exclusively by bottom-up processes occurring within the soil, and I'm going to show you guys how these ecosystems are heavily influenced by top-down regulators such as burrowing marsh crabs, who have significant multifaceted impacts on salt marsh ecosystems when they modify their environment through a process called bioturbation, where they excavate and disturb soils to varying degrees, causing varying effects. In this study, ecosystem engineers drive creek formation in salt marshes. Researchers conducted several field and mesocosm experiments where they observed the effect of crab abundance on creek head formation and growth. If we look at the graph here on the right, we can see the percolation rate, which is the measurement of water flow through the soil, in milliliters per minute on the y-axis, and different marsh zones on the x-axis. We see the platform zone, which is the more upland areas of the marsh. The live and dead zone is just where there's live versus dead cordgrass present. And on the far right, you can't see it because of my camera, but that's the mudflat zone where there is zero cordgrass present at all. And as we can see in every single zone measured, there is a significant increase in percolation rate associated with the presence of crab burrows, indicating an increase of flow through the system with the presence of crabs. So in the study, they concluded that an increase in crab density led to an increase of creek head growth, erosion, and percolation rates, as well as a decrease in plant biomass in the system. In this study, the importance of an underestimated grazer under climate change, how crab density, consumer competition, and physical stress affect salt marsh resilience, researchers ran several different field experiments and surveys to test the effects of both fiddler crabs and periwinkle snails on salt marsh resilience. So if we look to the graph here on the right, it shows us the percentage of stems grazed and the amount of crab burrows on multiple sites in three different zones of the marsh, being the cordgrass matrix, the die-off border, and the die-off. This is just showing the gradient of a dense cordgrass matrix towards a mudflat, basically. So the top graph shows us that there's a high amount of crab burrows along the die-off border of the cordgrass matrix and in the mudflat section. And the bottom one shows us that the most amount of stems grazed is occurring once again on the border and in the section of the die-off. And so this study concluded that an increase in crab density led to a decrease in cordgrass growth, and that it makes the salt marsh less resilient due to suppressing its ability to recover from stressors related to climate change that can decrease the amount of cordgrass. So the previous two studies help show how marsh crabs can decrease salt marsh resilience and increase habitat loss within the system. As we saw in the first study, crab presence increases erosion and creekhead formation and growth. This is important because having more creeks in a marsh greatly increases the surface area of the marsh exposed to wave energy. This, combined with an increase of percolation, can greatly increase erosion within the system. The second study highlighted how increased crab presence reduces the ability of salt marshes to recover from different stressors, things like drought, hypersalinity, and hurricane storm surge. This is because marsh crabs primarily live and feed close to the edge of cordgrass die-off areas. Crabs are not able to regulate their own body temperature, so it is important for them to be able to forage in the shade, which is why they dwell so close to the die-off line of cordgrasses. This unfortunately means that once cordgrasses encounter a die-off event, it is much harder for them to recover the space they lost due to herbivory pressure from the crabs and the added increase of erosion that comes with their burrow presence. In this study, what is the role of ecosystem engineers in New England salt marshes, a mesocosm study of the fiddler crab and purple marsh crab? Moore performed a mesocosm study where he observed the effect of both fiddler crabs and purple marsh crabs on salt marshes. Multiple mesocosms were arranged to mimic salt marshes found in New England and were introduced to varying densities of both crab species. They concluded that the presence of both fiddler crabs and purple marsh crabs increased soil quality and increased plant growth. This is due to the burrows promoting better soil aeration and drainage, which allows for increased nutrient uptake by the plants. In this study, the burrowing crab Neohelisae granulata affects the root strategies of the cordgrass Spartina densiflora and southwest Atlantic salt marshes. Researchers conducted a field study where they observed the effects of granulated crab presence on cordgrass root structure and found that an increase in crab burrows led to deeper, more homogenized roots. And this is because the burrows help oxygenate the soil, and the crabs living in the burrows defecating in them helps deposit nitrogen directly into the soil to stimulate plant growth. And if you look at the graph here to the right, it shows the redox potential of the soil on the x-axis, which is basically how much oxygen is in the soil, and depth on the y-axis, comparing soil with and without burrows. And as we can see, as depth increases, the soil without burrows in it has a significantly less redox potential than the soil with crab burrows in it does. These two studies help show the positive effects that crabs have on their ecosystems. They facilitate plant growth and promote a healthier marsh. They help facilitate plant growth by exposing more of the soil to the air when they burrow, increasing aeration of the soil. This helps boost root growth and efficiency, as seen in the second study. The increased redox potential of the soil allows plants to better absorb nutrients. So not only do crab burrows allow plants to absorb more nutrients, they also increase the amount of nutrients and overall quality of the soil. Most marshes are nitrogen limited and thus have a slower growth rate than what they might have if not for this limitation. However, crabs directly deposit nutrients into the soil when they burrow, which removes this limitation for nearby plants. Crabs can move more nutrient-rich soil down into their burrows to feed plants, defecate in their burrows to deposit nitrogen, and nutrients carried by the water can reach deeper soils utilizing these burrows. The increased oxygenation of the soil also helps increase its quality by allowing for increased biodegradation, which decreases soil organic matter, allowing plants to better absorb nutrients. Burrowing crabs also can promote long-term marsh health. It's because these burrows can help increase drainage of the marsh to help resist against damage from flooding, which further increases their resilience to effects of climate change. They also increase overall plant growth, which further increases the marsh's resilience to storm surge and erosion, as well as promoting biodiversity within the system. Using the information from these studies, we can see how variable the effects of burrowing crabs on salt marshes can be. Studies showed both positive and negative outcomes to crab presence, depending entirely on the local system. The studies looked at the same few crab species and same plant species, yet the results varied significantly. We saw lots of negative effects that crabs had on salt marshes, like their indirect amplification of erosion. This is caused by their ability to create additional creek heads within salt marshes, which increases the surface area of salt marsh touching the water, which can greatly increase erosion. This effect is also amplified by the burrow's ability to increase water flow through the soil, which means more sediment is carried away by the faster flow. We also saw more direct negative effects, like crabs' pressure on cordgrasses via herbivory. Crabs consuming cordgrasses can push their populations further inland. This effect becomes a problem due to crabs congregating around the edge of cordgrass border. Since crabs reduce growth rates of cordgrasses as they continue to stick by the receding edge of the grass, they continue to push it further upland and make it much harder for the grasses to recolonize sections previously lost. This effect means that when cordgrass experienced die-off from things like flooding, hypersalinity, or storm surges, they have a much harder time recuperating from lost land area, which highly reduces their resilience to things like the effects of climate change. We also saw lots of positive effects of crab presence within salt marshes. We saw that crabs actually increase plant growth in some systems by increasing the quality of the soil. They do this by aerating the soil by digging tunnels and also depositing nutrients directly into the soil as water flows into their tunnels and as they defecate and continue to move soil in and out of their burrows as they leave and come back to forage. This increase in plant growth actually helps to improve marsh resilience by helping to reduce the effects of erosion and flooding within the marsh due to this excess plant growth, which helps to secure the soil and stimulate a much healthier marsh in the long term. Some of the effects we saw were completely opposite to each other, despite being the same type of plant-animal interaction, just in a different place. In the same type of system, we saw both reduction and increase in erosion, as well as a reduction and increase in plant growth. This again shows just how extremely variable these effects can be even within the same type of system. The 2019 New England mesocosm study was the most interesting to me because it lacked the additional disturbances typical of marshes due to being done in isolated mesocosms. There were no tides, no wave actions, or any predation on the crabs. I think a similar study could be conducted in a similar environment in a place with high levels of erosion. For example, Louisiana has extremely high erosion rates within their marshes. A study similar to the one done in New England could be done in a low disturbance area to determine if crab presence could help increase marsh growth in those areas, making them more resilient for when they are no longer protected by the surrounding marshes. I think this research highlights the importance of considering top-down contributors to salt marsh health. Salt marshes were originally thought to be exclusively controlled by bottom-up processes occurring within the soil. This study demonstrates how top-down effects also have a significant effect on marsh health and should be further researched in the interest of further preserving salt marsh ecosystems. And that's all I have for you guys. Thank you so much for watching.